Hi, everyone. I hope you had a good time doing 8.1 notes in your homework. We're going to temporarily skip 8.2 and we're going to do 8.3 first because I feel like 8.1 and 8.3 are more related. And then 8.2 we're going to circle back to. Okay, so we're still going to be doing quadratic functions, so those are parabolas, and we're still going to be working in standard form. So let's go ahead and scroll down. Also, friendly reminder, you can print off my notes on my website, and they're exactly like the slides that we go through together. And you can do the notes as I teach them. You could also take notes in your notebook, or you can print off graph paper that I also put on my website. I just want you to take notes the best way possible so that you learn the best way. Okay, so let's go ahead and scroll down. Actually, sorry, let me go ahead and remind us what standard form is. So standard form is when it's y equals ax squared plus bx plus c. So we've seen this a lot. We were factoring this last chapter, and in 8.1 we were graphing this. In 8.1, if you notice, we were graphing everything, but we didn't have any b values. In fact, we were graphing quadratics that were in this form, y equals ax squared plus c. So what's going to happen today and on the next lesson is now the b values being introduced, and that's going to change some things. We're not going to have quite as many shortcuts as we can graphing like we did in 8.1. We're going to have a different approach because now we have a b value. So let's go ahead. I'm going to erase this over here and let's scroll down. What we're going to do first is just get used to identifying the a, b, and c values. So I'll leave it up here. So a is always in front of the x squared. So a is 1. If you don't see anything, remember that's a 1. B is -6. Take the negative with it. And then C is 11. C is your constant. C is the number that's all by itself. Okay, that's all we're simply doing on the several slides coming up, just identifying A, B, and C. So why don't you pause it here and you try to identify A, B, and C here and push play when you're ready. Okay, so A is -3, B is 24, C is 22. So simply just naming the coefficients in front of the variables. C is always my constant. Ooh, I just caught my error. C is -22. Always take the negative as well. Okay. So why don't you pause? This one is a little tricky. One of the values is missing. Why don't you identify A, B, and C? Okay, so A is 6. B is also 6. C is your constant. There is no constant here, so C would be 0. It's totally missing. All right, pause it and give it a try. So here we only have one term. This is also called a monomial, if you remember from last chapter. This has the x squared. So what's in front of the x squared is your a value. So a is 4, b is 0, c is 0. These aren't so bad, right? You're just getting used to identifying your a, b's, and c's. Then we're going to put them into work. All right, so here's 2 examples. Why don't you pause and identify both and we'll regroup. A is 1/2, B is 8, C is -9. And then over here, A is -1/4, B is 3, C is -2. So this one's just showing that fractions can be A, B's, and C's as well. Okay, so now let's talk about, let's actually get to this slide. I'd like you to write down this slide and, put a big, let me clear my screen first. Okay, so I'd like you to write down everything in this slide and, highlight it, put a big box around it. This is a very, very important slide. So there's lots of things you already know. All right. So the graph of a quadratic, that's something in standard form, is a parabola that either is going to open up or open down. So they're saying if A, your first value, is positive, we already know this. If A is positive, it's going to open up. And if A is negative, it's going to face down. We were calling that a flip in the previous section. Okay, so here they're focusing on A, the absolute value of A. They're saying if the absolute value of A is greater than 1, they're calling it narrow. We called it stretch. So if it was greater than 1, it would be a stretch. It would be tall and skinny. It would be stretching up. If the absolute value of A is less than 1, it would be called a shrink. It would be short and stumpy, which is why they're calling it wider. We call it a shrink. All right, so what's new today is how we're going to find our axis of symmetry, okay? So we're going to be focusing actually on these last 3 items in this chapter and moving forward. We're going to be finding our axis of symmetry, our vertex, the x and y value, and your y-intercept, okay? So your axis of symmetry is x equals negative b over 2a. We're going to be using that a lot. So I'm actually going to write at the top of the screen because we're going to refer to it on every slide from here on out. This is something you're going to want to have memorized. This comes up in every math class from here on out as well. And it's pretty critical. Okay, so your axis of symmetry, remember that's the line that goes straight through your vertex. It's where if you were to fold your parabola, it would be perfectly symmetrical, kind of like the mirror that it's looking in. Your vertex is either your highest or your lowest point. In this graph we're looking at, it's the lowest point because your parabola is facing up. And the x value of your vertex is going to be the same value of your axis of symmetry. And then your y value is going to be a coordinate pair that we're going to plug in, and we'll find that together. So we're going to find the full-on vertex. And then your y-intercept, that's where it's hitting the y-axis. This here is your y-intercept, is always going to be 0, whatever the c value is. All right. I know that's a lot, but we're going to practice it quite a bit. So let's do it. Oh no, I'm going to undo that. I want to keep my negative b over 2a here. I'm just going to erase the rest. Okay. So consider the function. We got y equals negative 2x squared plus 12x minus 7. They want us to find the axis of symmetry and then find the vertex. Okay, so we're going to start off simple. We're not going to graph yet. That's going to come in a little bit. So to find the axis of symmetry, guys, it's this formula at the top right, x equals negative b over 2a. Drew over the picture. I don't like that. Okay, so you always make it a practice to identify your a, b, and c value. A is negative 2. B is 12. C is negative 7. I see a lot of students not take the time to write A, B, and C, and then this is where little mistakes happen because you accidentally plug in the wrong letter. So it's quick to do it. I recommend it. You'll prevent little mistakes. Okay, so the axis of symmetry is x equals negative b over 2a. So all I'm going to do is plug in the variables b and a. So x equals negative, my b value is 12, over 2 times my a value is negative 2. So all I'm going to do is clean that up. So that would be negative 12 over negative 8. And then that would turn into, well, 2 negatives are going to make a positive. I'm going to divide top and bottom by 4, so that would give me a 3 over 2. Okay, so my axis of symmetry is x equals 3 over 2. We always put the x equals there. It's very good practice. Please do it. People lose points when there's not an x equals there, on like the SATs or something like that. So definitely put an x equals. Okay, so now let's scroll down to where it's asking for the vertex. All right, The vertex, guys, is always going to be a coordinate pair. Okay, it's an x comma y coordinate pair. The x value is going to be the same x value that this axis of symmetry is. So it's going to be 3/2 comma something. Now to find the y value, we've got to work for it. We have to, I have to scroll up for a second. We have to use our original equation, y equals all of this. I'm going to take the x value, plug it in here to find y. So give myself some room. Let me move my, there we go. Okay, so what I'm going to do to find it, and I'll change colors here. Let's go ahead and use pink. So it will be y equals -2, and for x, I'm going to put in 3/2 squared plus 12 times 3/2 minus 7. Okay, guys, so if you hate 3/2, you hate fractions, you can always turn it into a decimal, especially in this case, 3/2 is 1.5. That's a friendly decimal, so I always just suggest you do something that you're comfortable with so that you get the answer right. I don't want you to quit just because you see a fraction. All right, I need more room. I'm going to scroll up. Oh, I guess I can't. I'm totally running out of room here. So let me see what I'm going to do here. We can do this. So let's go ahead and simplify 3. So remember PEMDAS, you're going to do exponents first. So 3/2 squared becomes 9/4. And all that times -2. Plus, now I'm going to cancel the 12 and the 2 here. And I'm going to make that a 6. 6 times 3 is 18. And then I'm going to subtract 7. All right, so I'm going to draw an arrow and continue my work up here. Sorry, I ran out of space on our next example. I'll do better. So 2 times 9/4, where I'm going to cancel my 2 here, and I'm going to cross out the 4 here and make that a 2. So this would make, remember it's 2/1, so this would become -9/2. Plus 18 minus 7. 18 minus 7, that's 11. All right, so currently that's 11/1. So I'm going to go ahead and get a common denominator. I'm going to leave my answer in a fraction. So -9/2 plus 22/2. So 22 minus 9. Yes, I'm using a calculator. I'm terrible at mental math. That would give me 13/2. Which 13/2 is also equal to 6.5. So either answer is great. You can give it as a fraction or a decimal. So I'll leave it as a fraction just because my x value is a fraction. So my answer here would be this coordinate pair, 3,2, 13/2. Now I realize this one was really ugly. I picked an ugly one to do first, and then the other examples that follow, they're going to start off more simple than this, okay? So I'm going to go ahead and clear the screen, and let's have a fresh start on the next one. It's going to be friendlier numbers. I just like to hit you with a hard one first. All right, let me see. Let me make my screen view, zoom out a little bit, just so I have more room to work. Okay, so this is the same thing. Find the axis of symmetry of the graph of the function. So that's going to be x equals -b/2a. So one thing is I always do write the formula to also prevent mistakes. And then I'm going to identify my a, b, and c. A is 1, b is -2, c is -3. Okay. Now we're going to go ahead and plug this in. So it'd be negative. And now look, b is also negative. So be very careful with double negatives. Okay, don't lose them. All over 2, and then a is just a 1. All right, well, 2 negatives make positive. So then that's going to turn into 2 over 2, which is a 1. Oof, I told you guys this one was much more friendly. I did that on purpose. I hit you with a hard one first, and then we scale back. Okay, so that's my axis of symmetry. X is 1. Now to find the vertex, it's an XY coordinate pair. You know the X value is 1. So this line of symmetry is always going to be the X value of your vertex. Always. To find the Y value, you plug in X in the equation to solve for Y. So it'd be Y equals 1 squared minus 2 times 1 minus 3. So that would be 1 minus 2 minus 3. All right, so let's see, a lot of negatives here. 1 minus 2 is a negative 1, and then minus 3. So that would give me a negative 4. So my vertex will be at 1 comma negative 4. Okay, see, not so painful when they're not fractions. Yes, fractions happen, so we had to address it, but it's a lot cleaner when they're whole numbers or integers. Okay, so why don't you guys pause it and try this one on your own and then push play when you're ready. Okay, so let's find the axis of symmetry. So that is the formula that we're memorizing. X equals negative b over 2a. And let me go ahead and identify my a, b, and c here. A is 1, b is negative 6, c is 11. So then that makes x equals negative 6 all over 2 times a. So I also hope you guys notice, like, I actually take time showing me plugging in. I don't do this part of my head because I don't want to mess up on something so simple. A lot of mistakes, simple mistakes happen here. So this is a piece I take my time on. Plus, if you get this answer wrong, then your vertex is going to be wrong because B relies on A to be correct. So now I'm going to clean it up. 2 negatives make a positive. So it turns into 6 over 2, which turns into 3. So my axis of symmetry is x equals 3. Ta-da! Okay. So my vertex is going to be, and I like to start out, it's going to be 3 comma something. That's something I need to find. Remember, your line of symmetry is always the x value. So it's going to be y equals 3 squared minus 6 times 3 plus 11. So this will be y equals 3 squared is 9 minus 18 plus 11. Okay, now I just like to, once it's down to plus and minus, you just go left to right. 9 minus 18 is a negative 9 plus 11. I'm just bringing the 11 down, and that'll give me a 2. So my vertex is at 3 comma 2. Not so bad. All right, you guys are doing great. I know it. So let's go ahead and keep going. All right, so you know me well enough. Once we start to get comfortable, I like to bring in the curveballs. So there's only 2 terms here, so something's missing. Not a big deal. Let's go ahead and identify my A, B, and C. A is negative 1. B is negative 10. And where is C? It's gone, so C is 0. Also, I hope you're thinking, we haven't been using C much. We haven't yet. It's going to come up when we start graphing it. But for now, it's just good habit to keep labeling C. So X equals negative B over 2A. Okay, so then that turns into negative, and then B is negative 10. So you got a double negative there. I see it. All over 2 times, and my A is a negative 1. Okay, so lots of negatives here. Change to pink when I clean it up. So 2 negatives make a positive. And then I'm going to have 10 over negative 2, which further cleans up into just a -5. So your line of symmetry is at x equals -5. All right. So my vertex is going to be at -5, comma something. You guys already know by now, just be careful with negatives. Don't lose them. We got a lot of negatives in this original equation. So watch how carefully I plug it in. So y equals negative, parentheses, -5 squared minus 10. Oops, I don't need a parenthesis there. Minus 10 times -5. All right, I'm going to change colors here. Pink overload. Okay, a common mistake is people like to cancel these two negatives. We cannot do that because of this exponent. Remember, in PEMDAS, order of operations, the first thing you do after parentheses, parentheses means clean up what's in parentheses, and there's nothing to clean up in the parentheses, then you do exponents. If you did this negative times this negative, that'd be multiplying, and you'd be ruining it because you do exponents first. So please square this out first. -5 squared is a positive 25. Then this negative comes down. So it's a -25. And then here it can multiply because there's no exponent on this -5. So -10 times -5, you change those to positive, that'd be plus 50. So then that would clean up to be a positive 25. Okay, it's a big Y value. So my vertex is at -5, comma 25. Okay, let's clear the screen. Okay, why don't you pause and try this one? Okay, A is 4, B, don't fall for it, B is missing, B is 0. You actually do have a C value here, C7. Now let me tell you guys, when B is 0, that is great. That's gonna make life very easy, and check it out. So X equals negative B over 2A. So that would be -0. Oh, I love 0 so much, over 2 times 4. Okay, so guys, 0 over anything is just going to be a big fat 0. So please don't make it harder than it should be. So that's x equals 0. Oh, so nice. Now to find the y value, okay, so x is 0. Find the y value, just plug 0 in. So y equals 4 times 0 squared plus 7. I don't know if you guys can hear that piano in the background, but it sounds like my husband's practicing piano. Okay, so 0 squared is 0 times 4. That's a 0, guys. Love it. Plus 7. So y is 7. So your vertex is at 0, 7. Now, actually, I want to remind you guys of this. We were graphing this in 8.1. So you were graphing this earlier in the week. We were doing tons of graphs when there was no b value. Just to show you what this looked like. Ooh, that's ugly. Let me make a straight line here. I'm going to draw a coordinate plane here. Okay, so when there's no b value, you can actually look at this original equation. Since your a value is 4, I can see it's a stretch. And the 7 means it's going to translate up 7. So 1, 2, 3, 4, 5, 6, 7. So what's going to happen here is you have a parabola. You have your vertex at 0, 7. So you know that. We were doing that before even doing this equation. So your vertex is 0, 7. We know it's facing up. And then we just plotted a point to the right and to the left. If I plugged 1 in here, 1 squared is 1 times 4. It's 4 plus 7. That'd be 11. And so you'd have a point here at 111 and negative 111. Okay, so if there's no b value, you could actually use the shortcut. Oh, it looks like I'm getting a phone call too. Everything's happening at once. We'll decline that. It's my neighbor. Okay, so yeah, you knew how to graph these. And actually, if you know how to find the vertex using our earlier lesson, if you looked at this and you're like, oh, my vertex is 0, 7, you could use that method. And you know your line of symmetry is that x equals 0, whoops, which is just straight down. Okay, so what I did is, guys, I gave you 2 methods on how to graph quadratic equations when there's no b values. You can pick your favorite method. You know me, pick your poison. All right, it wouldn't be me without giving you a fraction. Don't worry, this one's not that painful. We can do this. So a is a half, b is 8, c is -9. I suggest you pause it and try it on your own, and then let's pick up together. So x equals -b over 2a. I always love writing the equation first. So it would be -8 over 2 times a half. If you want to make 1/2 0.5, that's fine. You're going to get the same thing. So then I would have -8 over 2 times a half. Well, that's 1. Oh, how nice. That's just -8. So my line of symmetry is at -8. Well, that came out nice. Don't be so afraid of fractions. So your vertex is going to be at -8, comma, whatever you find for your y value. So let's go ahead and find the y value. Y equals 1/2 -8 squared plus 8 times -8 minus 9. All right, let's get a new color to clean up. Purple. So y equals 1/2. Now -8 squared is a positive 64. And then 8 times -8 is minus 64. Okay. And then a minus 9. So half of 64 is 32. Minus 64. Minus 9. Okay, so I'm kind of running out of room, so I'm going to do it over here and finish it. So 32 minus 64 is a -32. And then minus 9, so that should give me a -41. So hopefully you guys are seeing, you know, your vertex can be all sorts of values too, okay? And there we have it. My vertex is -8, -41. Okay, so here's a nice multiple choice. What is the vertex of the graph of the function? All right, guys, so the only way to do this, because you have a b value, is you have to do x equals -b over 2a. So let's go right into it. X equals -b over 2a. And let's go ahead and identify a, b, and c. A is -3, b is 18, c is -13. Okay, so then that would give me -18 over 2 times -3. Cleaning this up. So this would give me -18 over -6, which would give me just a +3. Okay, so multiple choice is nice because you know your x value is 3, so A and B are not possible answers, so I'm going to scratch those off. And let's see. We're down to C and D. Let's go ahead and find out which one it is. So y equals -3. I'm going to plug 3 in for x. 3 squared plus 18 times 3 minus 13. Okay, I'm going to change colors. So this would then be -3 times 9. 18 times 3 is, I think it's 54. Let me just double check. It is 54. I don't want to make an error on these videos. Can't really go back and edit them. If you guys ever see me do an error, obviously same rules apply. Just email me and First person to bring it up gets a homework pass per usual. Okay, so 9 times -3 is -27. And then plus 54 minus 13. So -27 plus 54 is 27. And then I'm going to subtract 13. And that should give me, what is that, 14? It is. So my vertex is 3, 14. So it'd be D. Not so bad. Okay, so that is the end of today's lesson. You guys did great. When we pick up on the next lesson, we're going to start using this method to graph them. So please, please, please perfect your ability to find the vertex in your line of symmetry. Email me if you have any questions, and good luck on your homework. Thank you, guys.